everybody, and welcome to the flipped instructional recording for 2.03, a model of an atom. So don't forget that you do need to include your notes and guiding questions in your science notebook. And then if you struggle with note taking, I will be highlighting the things out of the lesson that you should include in your notes, and I'll also be answering those guiding questions. So be sure to jot down those answers. So with that, we'll jump into the lesson and go ahead and get started. So we're talking about the model of an atom, and it's really, is it really possible to change elements just by removing protons? Atoms are so small, though too small to see. So how would you know where to look or how to go about removing protons? There must be a way. So here are the lesson goals and then the 3 guiding questions that we are going to answer. So the first one, let's take a look at. So we're looking for it as we read through. Number 1 says, why are scientific models important? All right, so when you're building an atom, it says, can you just add or remove a proton from an atom to change an element into a different element? Sounds easy, right? Before you go about answering this question, review what you already know about atoms. So from previous lessons, we know there are protons. Protons are positively charged, and they are found inside the nucleus. The number of protons determines what element an atom is. So that's an important thing to have in your notes. Actually, that whole sentence would be great. So if you're watching the recording and you want to pause it so that you can jot that down, you can do that. Neutrons are next. They are located in the nucleus as well. They do not have a charge. They are neutral. So atoms of the same element may have the same number of protons, but a different number of neutrons. So in that case, that is called an isotope. So the 2 atoms are isotopes of the same element. This would also be a really great thing to have in your notes. And finally, electrons. This is the 3rd part of an atom, and they have a negative charge, and they are found moving around the outside of the nucleus in different energy levels. And the amount of space the electrons have to move outside the nucleus is much greater than the size of the nucleus itself. So the problem we are taking a look at is now you need to know, or now you know what an atom is and how it is composed. So you can't see an atom with the naked eye because it's too small. How do you go about seeing the atom then? What can you do? You build a model. Scientists, architects, and engineers use models all the time. Models show how something works or looks when it is not feasible for the actual thing to be seen or built. If things are too big or too small to see, a model is used. Engineers make models of machines before starting construction. This way, clients can see if and how it'll work without wasting a lot of time and money on building the actual machine. Models also make it easier to make changes to an idea. So can you use the concept of a model to build an atom? So if you remember, why are scientific models important? They listed a couple of things here. They help you to see things that might be too big or too small, too big to make or too small to see. And they also allow you to edit or kind of make changes to the work before you have the final product. So how to build an atom. Because they are so tiny, atoms are impossible to see with the naked eye. To truly understand the complexity behind changing one element into another, it is important to understand the structure of an atom. You will build and study a model of the atom to help you understand more about it. You can make a model using the complex materials suggested here, but you can also use materials that you have on hand. And if you prefer, you could also draw your model. So here are the optional materials that you can use. You will be taking a picture of your model and submitting it in your science notebook for the notebook activity in this lesson. So time to get started. Follow these steps to create your physical model of the atom using some common household materials. If you prefer, you can use these directions to create a drawing of your atom. Substitute different symbols or colors in place of the materials. So here is the procedure. Notice there are numbered steps. Gather your materials, and you will build a model of a helium atom. So it's not just any atom, it is specific to helium, which consists of 2 neutrons, 2 protons in the nucleus, along with 2 electrons outside the nucleus. So it's telling you exactly how your model should be set up in step 2. And then it says first color 2 sesame seeds with the permanent marker. So remember, if you don't have sesame seeds, use anything else. So find 2 things that are the same, and that is going to represent the neutrons. Then it's asking you to use rubber cement and attach those seeds to 2 plain sesame seeds. And then from there, you're able to see that you're combining seeds to represent protons and neutrons, which are going to make the nucleus. So together you have the 2 plain and the 2 colored sets of sesame seeds put together. The plains are the protons, the colored are the neutrons. So you're differentiating because they don't look exactly the same, right? We don't want to mix them up. We want to know that one's proton, one's neutron, and that is a neutral charge. So you'll put those in the nucleus. You're going to let it dry for a few minutes. And then it said make a ball of fiberfill that is approximately 10 centimeters in diameter. So it's not very big. 10 centimeters is really small. And you're going to put the 4 sesame seeds, that is your nucleus, into the middle of the fiberfill puff. And then you're going to glue the 2 poppy seed electrons to the outside of the fiberfill in the different locations. So you've got the nucleus, you're tucking it into the middle of the fiberfill, and then you're putting the electrons, whatever you're using to represent your electrons, on the outside of it. So again, draw it, make it bigger, however you want to do that. So here's the notebook activity. You'll need to include a picture of the atom model. And then using what you've learned from there, we want to answer these questions. So let's look back and look at the guiding question number 2, which says, what does the structure of an atom look like? And we talked about that, and we also kind of saw it before. Let's see if we can go back here. Kind of the structure of an atom, we talked about it, where we've got protons in the middle in the nucleus and neutrons together, and then we've got electrons orbiting around the nucleus. So that's how you would answer number 2, just kind of explaining what that structure is. And then number 3 says, how would you change an atom from one element to another, and why is doing so a challenge? So what we've learned when we looked at the notebook activity was that we're specifically going to use 2 protons to make this helium atom. Because if you look at a periodic table, helium is element number 2. So 2 protons is what is defining helium as helium. If we take it away and we only have 1 proton, now we're talking about hydrogen. So every time you add a proton, you are changing the element. So that's how you would answer number 3. So back to the science notebook activity. On your slide in your science notebook, you're going to include a picture of your model or a drawing, and then you're going to answer questions 1 through 5. So in the models, what particles do the colored and plain sesame seeds represent? And what particles do the poppy seeds represent? So if you changed your model and you did not use sesame seeds and poppy seeds, then just indicate it's asking you what are the protons, the neutrons, and the electrons. So you're just telling me there what in your model illustrates those things. And then number 2, what does the fiber fill represent in the model? And this one's kind of tricky because we know the protons and the neutrons together make up the nucleus. And then we know that the electrons are kind of stuck on the outside of that fiber fill. So they're kind of representing number 2. It's the fiber fill is kind of the structure of the atom. The nucleus is inside. So you can just say as a whole, it's representing kind of the electron cloud or the structure that's holding everything together. And then in an atomic model, what particles are found inside the nucleus? So you should easily be able to answer there the 2 things that we put in the nucleus and what is found on the areas surrounding the nucleus. So pretty easy. If you even go back to the pictures at the beginning, you're able to see and determine what is found outside. And then why are the poppy seeds placed in different places, not together? So it's talking about the electrons and why are they in different places? And we know if you even go back to this slide, it talks to you about the electrons and it says that they are moving around the outside of the nucleus in different energy levels. So that's why they're not placed together. All right, so we have gone through all of the guiding questions and we've gone through the science notebook activity that should be submitted as well. So in the activity review, it just says to go back to the proposed problem. How easy is it to change an atom from one element to another? An element is defined by the number of protons the atom has. That would be a great thing to have in your notes. To change the number of protons, you must enter the nucleus to add or remove a proton. So on guiding question 3, when it talks about why is this a challenge, it says here that would be very difficult to go into the nucleus to take out a proton. So look at the physical model of the atom you created, and do you think it's easy to get to the nucleus? Probably not. There are 2 major obstacles. So it talks about you have to travel through the electrons that are orbiting the nucleus, and traveling through a cloud of electrons would be difficult. It takes a lot of energy to remove a proton because the protons are attracted to the electrons orbiting the nucleus. So imagine like opposite charges attracting, it doesn't want to leave there. And then the distance that the nucleus to get there from the electrons is really far. So it would take a lot of energy to get to it. Atoms can change from one element to another, but it takes an immense amount of energy. And that is a really important statement to put in your notes as well. And this is commonly seen in the field of nuclear chemistry. Subatomic particles are shot into atoms to produce energy and change the proton number of the atom and thus changing the element. So you can see for guiding question 3, it is a pretty complex thing to do there. So hopefully you were able to get through everything you needed. You have notes to take and you've answered the guiding questions. We've read through the lesson. We've done the science notebook activity. And you want to make sure you get all of those things in your science notebook. And from there, look for the flip follow-up session for your next Class Connect. If you need help with anything, please come see me in Help Lab and have a wonderful day.